Hello, Dr. Pi. Could you show us what the Caesar Cipher is and do it with object-oriented programming? Thank you. Bye. Don't forget to subscribe.
Hello. Yes, so today we are looking at the Caesar Cipher. In cryptography, a Caesar Cipher is one of the simplest and most widely known encryption techniques. A Caesar Cipher is as easy... The Caesar Cipher is easily broken and in modern practice offers essentially no communication security. So, pointless, but I thought it'd be a nice idea just to do a program for it because it's quite a common example to do, and there's a couple of nice little things in it which we can learn. What does it do? Well, if you take the alphabet, the English alphabet, 26 letters, what it does is it takes the original message and shifts the characters. So if it shifts by 3, then a B becomes an E, and so on. The number of characters you move along is going to be called the key. And there is a man with no eyeballs. Well, he's got eyeballs, but doesn't look like he can see what he's doing. And there we have a construction of 2 rotating disks with a Caesar cipher that can be used to encrypt or decrypt the code. That will actually rotate to decide the size of the key, so how many characters you're shifting it by. Well, let's without further ado, if you're more interested, then Wikipedia / blah blah blah, whatever, like it, all what it says there. Right, let's go. I've had a practice at this already, so I didn't want to bore you with some half-assed, quarter-assed attempt even. So first thing I'm going to do is import string, because that will allow me to use the string.ascii underscore lowercase function, which saves me writing out 26 letters. So we'll call that alf, not alfie as in Alfie Noakes, alf as in alphabet. That's the ASCII. No, it's string dot ASCII lowercase. I always do that. No brackets on the end. Right. Gonna make it. So we want to have. For this example, we'll have all of the letters of the alphabet and numbers 0 to 9, and we'll have a space as well. So symbols can equal alf, so it will equal the alphabet plus 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and we'll have the space as well. So if you have a phrase like hello, how are you, we'll be converting the spaces as well. All will become clear. The key, this is the bit that decides how many letters you shift each, you sort of encrypt by. So key, let's do 13, which is 13 is coincidentally what is used with ROT13. ROT13 is another type of encryption which you can investigate if you want. I'm going to start with some sample text. Hello, and we'll do, I want to use a word with two of the same letter because that's quite an easy indication that you have got your program working correctly, because those two letters, once they've been encrypted, they'll be shifted along by the same amount, and you'll see. Right, let's, before we start, let's say print f string, the character set is, and then we'll just display symbols. So nothing to just setting up the variables so far. So here we go. We want to know the length of the symbols. Because if we go past the end of the length of the symbols, we want to sort of recycle the numbers, or recycle the. We want to recycle the new index that we're assigning to the numbers. You'll see once it's working. I saw this in an example. So they were also making the program do encrypt and decrypt. So yeah, I've shamelessly copied that. I make no apologies whatsoever. If you don't like it, swivel. I wrote this as a test already, and it needed tidying up, so I'm going to make it into a class, which is a good thing to be able to do. It actually makes everything very neat and self-contained and reusable, I guess. So the variables we will be passing or instantiating with our class will be the key, which is how many characters you do that shift by, tx, which is our text that we want to encrypt, and mode, which won't actually be used for the purposes of this video, but it will be in a future video, which that's going to be an absolute bonus for everybody, isn't it? I bet you can't wait. So self, tx equals tx, self key, self dot mode equals mode. This is the boring bit. We'll get to the fun bit now. Let's go. So make a function called encrypt. Self as ever for any function or method. What have I missed? We need to so when we create instantiate a class, we will be passing it the key, the text, and the mode. We need to, so they will already be with that object. So when we run the function, we just use all of that already, and we will have, we will need to build a string or append to a string as we loop through each character in tx. Because obviously we'll start with H, then we'll add 13, or the next E, add 13, L, add 13, so on. So we'll return something called result, response, whatever. If modes equals 0, which it will for the purposes of this, it'll always be 0, because we are encrypting, we're not worried about decrypting just yet. So for every item in tx, the string tx, so for I in tx, so for each character in tx, so if that character is in symbols, if I in symbols, this is the good bit. We want to add the key. So A, you add 13, so then that will take you up to, it'll convert an A into what, M? No, N probably. So ABC would become 14, 15, 16, something like that. Let's try it. Check for wraparound. Because what we're going to do is we're going to recycle the numbers. And this will make sense in due course. And we're going to find the index of the symbol character. So if the character's in tx, then we're going to check it's in symbols, and then we're going to get its index from symbols. So we're going to find, so A will be 1. So we're going to find that index, so A is 1, and then we're going to add the key, so that will make it 14. But we don't want to go past the top limit, which is the length of the symbols. So LSM. So LSM equals the length of symbols, so that will be 26 plus 10 plus 11, that's probably 37, 36, 37. So if our letter plus the key goes past 37, that'll be nonsense, because once we get past halfway, we want to then use an index value back at the start of the alphabet. Because we have to, once we go past halfway, we need to then start using the ones at the start. That's the best way I can explain it, which is not very well, but you will see. New index equals symbols dot find Yeah, so if the current character plus 13, say we're using 13, so A plus 13 takes you up to 14, so that's still inside the length of the symbols, which we think is 37. Once we get near to the end of the alphabet, we'll have 26 plus 13. That'll take us off the end of the symbols variable. So then we will, instead of adding, we can then go back 13. And we won't get any duplicates that way either. We won't ever have any fatal embrace, collision, crash. New, so let's, I'm going to copy that, because all I need to, copy that, and then same there. So actual fact, if If a symbol.find is character A, then A plus key of 13 takes you up to 14, so the new index for A will be 14. If the symbol was to say Z, you don't want to do Z plus 13 because that will take you off the end of there. So then you go back to the start again. So then you do symbols.find, so Z, which would be what, 26. So then you do 26 minus 13, so that gives you 13. Trust me, I'm a doctor. Doctor fucking pie. Symbol. So then the result. So for each, we're gonna loop through this loop. I really should have a webcam because I'm moving my hands pointing at the screen and you can't fucking see it. What a symbols. So the result is symbols, and then we want the new index, which will be the old index plus 13. So new underscore index. What the fuck? You just beeped at me, bastard. Then we want to return. This is why we, this is why we needed res, because res is going to gradually build up as we loop through. Let's put a nice message saying the encrypted version of TX is res. There we go. And then I'm just going to put an else and then a pass just for, because this will be for probably the next video that I alluded to earlier. That will be if mode equals 1, which will be when we decrypt a phrase. Not much point encrypting a phrase if it's never going to be decrypted. You might as well just throw it in the bin. Just trying to remember how to type Caesar. It's the wrong way around really, isn't it? I think it's Latin, obviously. So when we instantiate, let's just create a class, an object called lowercase c equals Caesar key tx mode will obviously be naught, which it will get from up here. TX it gets from there, and key it gets from there. And then when that runs, it's just going to return a value, but we're not going to see it. So we need to print c.encrypt. I always type this thing. RYPT. And that should be it. Let's see what it fucking prints, shall we? What the fuck? Why is that not working? Invalid. Equals you. Right. What? Yeah. So it's silly little things like this that always get you, isn't it? Alf. Right. So far, we've had a missing equals, we've had a missing bracket, and we've had a typo. Not looking good, is it? Here we go. The character set symbols, that's fine. No, it's not. Why is it doing that? F strings F stands for fucking get it right, you idiot. Right. The encrypted version hello to you is you. No, it's not. We have got a monumental fuck up here. What's going on? I think I've got my indentation wrong. Let's try that. Yeah, the return needs to line up with the 4. Let's go. Well, hey, right. I'm looking at that and thinking it's correct because we had a word called hello. So hello had 2 L's in it, so the L's have changed to Y's. We had 2 spaces, so we had a space after the 5th character, so it's turned a space into an X, and then we had TO2, and then we've got another X, which is space again. So at least it's consistent. Right, let's do a very basic check. If we do ABC, run it again, and then that should be MNO, something like that. Oh no, NOP, yes. So ABC should be, no, that is ABC. Let's see what MNO changes to. We're adding 13, so that takes us off the end of the alphabet. So that will be 0, 1, 2. Oh, Z 0, 1. I'm 1 out there, sorry. Let's do NOP. That should get changed to 1, 2, 3 then. Sorry. OPQ should go to 1, 2, 3. Yes. Correct. Let's summarize what we've done here. We have used a string library to help us make the alphabet. String.ASCII lowercase gives us our first, well, our 26 characters of the alphabet. Then we added all the numbers and a space. So we've got a string, which is A, B, C, D, E, all the way up to Z, plus all the numbers of the alphabet. Yeah, I know. Little gag there for anyone who's still bloody watching. Key 13, that's how much we transpose it all by. TX is the sample text that we put in, so bollocks. And that changes it to 0, 1, YYV. So yeah, you got 2 L's again, YY. The character set is, so we're just displaying what the set of characters is. And there we go, that's what we've created as our character set. There's a space on the end, which is what you don't see, which is why I was getting my sums wrong. I was out by 1. We've made a class. We've given it some sort of future ability as well, because we've put mode in as 0, which is encrypt. Next we'll do decrypt, so we'll set mode to 1, and then we'll write the decrypt function, and then when we call it, we'll either pass it 0 or 1. So we've initialized key, the text, and the mode, and then secondly, when we instantiate the class, we then run the encrypt function, which it loops through every character in our phrase, and then it checks what its index is in symbols, in our symbols variable, and then it adds 13 to it until it goes off the end, and then it switches and it just instead of adding the key, it subtracts the key. And then we return that variable called res, and then that gets, when we instantiate our class, our object, we then get a return value which we can then print using print c.encrypt. So yeah, I'll put the code down below. Feel free to copy it, modify it. Obviously referred to Wikipedia, and my other source was, it was one of the really nice no starch press books. I think it was called Cracking Codes, the Code Cracking Handbook or something like that. I can't remember. I will find it and put the link up for you for your amusement and education and pleasure, if it is pleasure. If it's not, well, at least you've not wasted the past 25 minutes watching a cat video, because what does that actually achieve, really, watching a cat video? I know they can be cute, but try watching monkeys, they're good. And also, if you're on YouTube, watch some swamp videos, because they've got some fucking amazing, I was going to say crocodiles, but they're alligators, aren't they? Go and watch some alligators on YouTube, and then if you're allowed to go outside, go for a fucking walk. Later, bye.